So here's Sheffield. We've been a month off finishing for the last 6 months, and here's why. Welcome back. We thought we'd give you a quick interim update of where we are with Sheffield, because it's proving to be a bit of a mission and it's taken a lot longer than I thought. The optimist in me is always there. If you remember, back in the autumn last year, we had some updates of where we were then, and since then we've progressed royally along with building Sheffield. To give you some idea of what's here, Sheffield, there are about 6 or 7 baseboards, and I'm going to explain the construction. They're all liftable at this stage, but in essence, Sheffield, for those who haven't seen the previous videos, is our freight marshalling yard for the whole of McKinley. One of the things we want to introduce with McKinley in this next phase, besides the time machine, is to make meaningful use of freight movements, which isn't being done very often in UK model railway terms. And we're using stuff like RFID, which I'll touch on again in a moment. So Sheffield, just to give you a quick overview, consists of, to give you some idea of what we're doing, we have the hidden main lines at the back, and we have the visible main lines running through at the rear. We then have 3 arrival departure tracks for goods trains to come in and go out. And then in Sheffield, there's an engine shed down there behind where you're looking at me. And then here we have 2 opposite facing sorting sidings with their own head shunts. And so what I'm standing in front of is yard D, which is the west yard, and then down there is yard C at the east end. And the purpose of Sheffield is that a train will come in with goods vans that are designed or destined to go to different locations on the layout. The train will consist of vans and wagons for Manchester, Birmingham and London. The train will be pulled in and it'll be marshalled and sorted. The wagons will be sorted into the individual sidings that will be destination specific. So at 2 o'clock there might be a freight train for Manchester and they're building it up in this track here, and then a 2:30 train for Birmingham. So the train is broken up and put into the relevant sidings. The role of the computer with Sheffield is simply restricted to the 3 arrival departure tracks and the exit through this point work and going on down out there to the main lines. None of the shunting and the marshalling work is done by computers, it's all operator managed. And part of the process, which we'll explain, if we talked about in a previous video, was to do with RFID, and you can see these big green squares and then holes cut out for future ones that are going to go on these tracks when we join these boards up. And behind this wagon, or sorry, underneath this wagon is an RFID tag, and the whole idea is that as it goes into a track it will go over this and that will record its location. The computer will know that that wagon is destined for Birmingham. It will also know that this siding is being designated at this particular time for trains being built up for Birmingham. And so the operators, when they get it right, will get that wagon in there. We haven't figured out how this is going to be, but if we know the technology works, we've just got to stitch it in. So this is how it is designed to work, and that's got to be tested later in the year. And all our wagons will have these simple tags underneath. And we're using a company called Excel, which is a UK-based outfit, and they're very responsive and very proactive in doing something with us. And if it can be commercialised or made available later in the year, we'll facilitate doing that. But right now it's very much an R&D exercise. This level, Sheffield, it's fundamentally part of the operational level of the layout. And so Sheffield, which is what we call level 4 in this room, comes around behind me. The main lines run round here, and it goes into the level 4 staging yards here. Those tracks there go all the way round to there, and it's designed so that we can hold trains here from virtual destinations, maybe like Glasgow, Edinburgh, Carlisle, and they will come through into Sheffield with wagons to be delivered to Birmingham, Manchester and London, and vice versa. And because the loads inside a van, such as this, It's just a brown van, and that's the problem with British Railways, is they're all brown vans predominantly. And so it's very hard to identify where it goes, which is why we're using that technology. But this will be our off-layout storage for virtual trains that will come in for van loads of beer or for bicycles or for parcels to be delivered to relevant stations on the layout. And that's what this will serve. This level 4 goes all the way around here, and over here the track work comes down and it will go through to London, and the other track will go through to there. And that bit all the way around there to here has already been tested and proved. We know it works technically. So we're building the Sheffield component, and what we've done in addition is I didn't want to go through and bust the railway into the existing layout while we're still building this. And we've got many months worth of testing to do on this railway. And so we devised a temporary loop that literally diverts the line around in a great big sort of horseshoe fashion and joins up with the existing track there. And our goal later in sort of end of March and April through the summer is to run this layout in conjunction with the other layout, but they're not physically connected, so that we can start to operate on Sheffield and Hades and the virtual storage yards in a simultaneous way with the other layout without getting the dirt and dust and debris from this room into that room and running that clean stock into here and having trouble. So once we've finished this, there's quite a lot of testing and proving to be done with the software, with Loconet and all the other components. Let's take you now and look at some of the boards that we're doing and what's underneath them. And we can see the work that's gone on underneath the track work there. The crucial thing about this to just bear in mind before we get distracted by all the red and black and wires and tortoise motors is, why did we hinge these boards? There are two reasons for that. The first thing was that we've got no working room between the storage tracks underneath and this level. We built the storage tracks in a different way because they're very repetitive and they can be bolted down, but this was much bigger and very unique, and therefore we hinged it at the back. But those hinges are there for construction purposes only. We will be laying the tracks across these joints and putting these boards down finally once we've tested everything, putting the tracks in, and we don't envisage ever having to take these boards back up again. On the existing layout in Manchester and London, those boards are all hinged and they're permanently hinged, and you can lift tracks up and down. But we've never gone there. We've never had to lift those boards up. And generally it's easier to work underneath to replace one little faulty item than take the whole world off of that board in order to fix it. So we've never had a serious problem. But if we did, it would mean we would have to cut through the tracks, and we just decided that it's such a rare thing, we'll live with that. So under here, there's just a sea of components, but let me try and break it down because it's very repetitive and quite simple. There's a ton of red and black wires, and that's predominantly due to the false principle, in my world anyway, of there's only two wires in DCC. The reason it's different here is because we use a lot of power zones and block detection sections, which I'll explain in a while. So putting aside those red and black wires, if you notice that the block work has been cut out and marked on the underside of the board, so we knew where the wood was and where the through works were. So this cut through here allows us to put wires through that part there. The previous boards, we didn't do a particularly good job at it, and I'm very reluctant to show you the underside of this board. It looks like this, but you would not believe it. It's like a piece of Swiss cheese with all the boards that poor old Martin and Steve had to cut out and reposition and realign as we realised we needed yet another tortoise point motor. Down here, we've got the tortoise point motors. I'm in love with those really. We've got about 150 on the existing layout, and only 2 have ever failed in about 20 years. And the other thing that I really like about them is that they've got 2 built-in switches. The first we use to control the electro frog, and the second, which I think might be a feature that's unique to Digitrax, is there's also a point position feedback, so that when we power on the layout, because of the position of this switch, the devices such as the DAC20 or the Digitrax DS64, both of them control points electronically, will feed back to the command station across the network and therefore to the computers the position of the points on the layout. That means, in simple terms, I do not have to go around and set hundreds of points to a predetermined start position. Their positions are all recorded at startup time, every time, without having to move anything. And so that's why I think they're great. And all these chocolate blocks that you can see here, they're 8-way, and it's simple because there's just 2 for the power to set the direction on the tortoise, and then there's 2 banks of 3, each has a switch. 1 bank of 3 does the power to the frog, and the other one gives the feedback back to the system I talked about before. In addition, underneath here we have the infrared detectors. On this board we've got 3 stop sections for the arrival departing trains, and we've also got 2 on the main line for operational sections. And associated with each of these infrared detectors we were putting a signal mast in, which will be controlled by the SIG M20 board. That one, in the arrival departures there'll be simple starters, so red and green, but on the main lines they're 3 aspect. But they're not on, but the electronics is down in the board beneath. We simply have the signal masts and wires. In addition, you can see these black cables here. These are the antenna leads for the RFID devices. And we haven't fitted them yet because we're waiting for delivery. These are the boards that we will have to fit in each of the areas. You saw those green spots on the top. So on this board there's 6 for the sidings and 3 for the arrival departure tracks, and we put 1 of these on for each of these. This company that's building these boards, they're very proactive, and they are planning to produce a board that we can attach up to 8 of these devices on. So in all these sidings we won't be using 1 of these per siding. We might use 1 for 4 sidings, or up to 4. I've noticed that we've wired this red and black, and that's probably wrong. Our wiring standard was dictate that this would be blue and white because it's a 5-volt supply to these, so we'll have to actually take these off and resolder them. So in essence we've covered pretty much everything that we need to cover underneath here. You can see we've marked it out, we've chiseled away tons of the board work, we've got the point motors, which are the dominant component together with all the track wiring, the infrared devices. The final thing to just quickly note on is we're using these Electro and Couplers. So these are energized when you put power through them, and they don't work if you're just pushing a train across them and it's not energized. A friend of ours is designing a little board that will allow the operator to press a button and the Electro and Coupler will be charged for 5 seconds and then automatically go off. We will have these little buttons mounted on the fascia here directly in front of these Electro and Couplers. And on this track, on this particular board area, there's probably 4 or 5 for the sidings and 3 for the acceptance arrival tracks. And where they press the button, it will come on, and therefore they can get on with shunting the engines and the wagons to get them uncoupled, rather than having to hold a button in and then move it. As and when we've got that technology proved, we'll publish it in one form or another so that you, if you want to build this yourself, you can do so, because I think it's quite a useful feature. The other thing to just note is you'll see these big chocolate strips up here. What we wanted to do was not have lots and lots of duplicate wires going down to the boards and then join them up down there, because space in the trunking is at a premium. And so where we have short sections of track that are on different boards in one power zone, we've looped the wires through to here to ensure that we've got them all in the right zone. And so these interboard joiners, there's one at this end and there's one down here at this end, which you probably can't see behind all the woodwork here. And that allows us to do all these tests and make sure at the testing phase that all this is checked up, and if it isn't, we can come in here and alter them there. Once we've done all that testing, we'll then screw these boards down and they won't come up again. But we've still got to fit the RFID detectors, which they're not particularly big, and there's a lot of space here in the, he said, searching vainly to find something that could hold a postage stamp. But we'll find a way to fit them. And I think that gives you a good overview of what's underneath our boards here at Sheffield. One of the crucial things in any large layout using a digital environment is power management. There's 2 levels to it, maybe even 3. The first obviously is the amount of power you're going to supply to the track work. We will have one booster that supplies the whole of this Sheffield layout. That's the engine shed, the two sets of sorting sidings, the 3 arrival tracks and the main lines that run at the back. That will be sufficient for this area of track work. But what you need underneath it is some power districts or power management, not to do with the amount of current being supplied, but the problem you have with a large layout like this is if you have a short circuit somewhere, the problem is if it's just the booster for the whole of Sheffield and I go over a point here, or somebody, so behind where you're looking at me, runs into a point in the engine shed down there, the whole of Sheffield shuts down. And that's a nightmare on any layout. I've seen it at shows. And we've taken advantage of that PM42 board, which is a Digitrax board, and it has 4 power circuits on it, 4 power breakers. And what we've done is divided Sheffield up, and we have a need for about 8, or rather 7 plus 1, and I'll come to the last one in a minute, power districts. And you're thinking to yourself, 7? And that partly explains the amount of black and red wiring you saw underneath here. So how do we get to 7? Well, let's walk from the back to the front. We have the red and the green main lines, and they're repeated over here, and therefore they come around. But each of those main lines is on its own power district within the Sheffield board area. So that's 2. We have this set of sidings here, the west end sidings, and over there the eastern sidings. If I'm shunting here and I go over a short here, it's really important that I don't affect anybody else doing it. So they're shunting their wagons there. So I'm going to be aware of what I've done wrong. So what we've done is we've put a power district here, which is what these set of green ropes, you might be wondering what they're all doing here, but it's just to help clarify things. You can see that this is basically shaped around the west yard. And the east yard has an equivalent set there. So we've got 2 for the main lines and 2 for the yards, we're to 4. Add on the engine shed as a separate area because engine drivers are terrible. They're always going over points. So that's 5. And then we get to the arrival departures track. And we looked at this, and our problem here is that the point work for the arrival departures track is down that end. And there's also down this end. They're a long way apart. And if one operator makes a mistake down here and I can't work my train, it's not going to be obvious what's happened. And so we broke the arrival departures tracks into 2 power districts, which then has an obvious consequence of that is you've got to then double up on your occupancy. But we thought it was a price worth paying. So 2 main lines, we split the arrival departure zone tracks into 2 zones, so that's 4. The east and west yards is 5 and 6, the engine shed 7, and that odd one I talked about, we converted into an auto reverser, which the PM42s you can just dictate what they do for the turntable in the engine shed, and that makes 8, which uses 2 PM42 boards. Now, the next thing, which has nothing really to do with power management, but is to do with occupancy and working out what you need, or what the computer needs, should I say, is where you're going to put that. The computer's only going to be delivering trains to and from these 3 arrival departure tracks here, and it will be running trains around the main line, both visibly and invisibly. So in one sense you might say, and I put these little tags, I hope you can see them on the track here for the 3 arrival tracks here. Each of those will require a BDL 168 detection zone. The point work here, which is part of the throat for coming in and out the yard, will need another one. So if I was being clever, I'd nick one of these and put that there to indicate that we need 4 for the arrival departure tracks here, 4 BDL sections. In all the manual yards in the engine shed, on most layout areas, we have never put occupancy detection in, but we don't quite know how it's all going to work with the RFID in these sidings here. And so as a precaution, we've put occupancy in the 6 sidings here and the 4 sidings over there in the other yard, so that we can detect if that siding is empty or not. So I don't know if we need it, but we put it in, and that explains why we have so much red wires underneath here, because normally you'd only have the main lines and your arrival departure tracks. The areas that have computer access would be requiring the block occupancy, and then you also have the infrared detectors here, here and here for stop positioning, but they're nothing to do with power management or computer. Well, they are computer control, but it's not power management. So you get some idea now of how we've devised the layout for power management for boosters and also the occupancy. One bit I haven't touched on is none of the point work in these sidings down here, none of this point work down here has occupancy sections. There's no value in that to us because it's being manually operated by a shunter driver. It's simply just, we might want to know that the Birmingham train has been completely removed from this track. It's now completely empty and we can repurpose that track for a different operation. And that's going to come out in the test and the proving. So I hope that gives you a quick idea of how we've got the boosters, the power management and the block occupancy working in Sheffield. What I'd like to do now is show you the power board arrangement underneath the layout. We're going to show you the ones we've used for the staging areas or the holding areas in Hades, and I'll identify the differences for how we're going to be wiring Sheffield. We're going to be using 2 boards for Sheffield rather than 1 for each of these Hades levels A, B and C, because there's an awful lot more equipment going in, and right now it's just a sea of wires, which you'll see in a minute. But let's just go through the equipment as we intend to use it. Here we have the booster. It's a 5 amp booster, and that will be one of those for the whole of the Sheffield pair of boards. The track power comes out of that through that amp meter, which we've mounted on the fascia to show us what the voltage is and the current draw, which gives us a very quick summary indication if we've got problems in any one of the districts, or rather the booster districts. Those wires go back out, and on this board we're using 1 PM42, which gives us 4 power districts. On Sheffield there'll be 2 of these boards to give us 8. And from these, the wiring goes out through these devices, which are the occupancy detection boards, the BDO-168s. On Sheffield we need 3 of these. This board there are 32 outputs. On Sheffield we need 3 to give us 48. The point motors are controlled on McKinley. We've got the DAC-20s, which control 8 points, and we need 7 of these boards for Sheffield because there's 50 points on Sheffield board. And then what we don't have on this board, which we do on Sheffield, is we've got the SIG M10 boards, which we're using to control the signals, you know, the starters and the 3 aspects I mentioned earlier, and they have the inputs for the infrareds, whereas for the lower boards we don't use actual signals, and we will monitor them with these particular ones here, which these ones are the SYN 16s, which we won't be using in Sheffield. So we have, to recap, 1 command station, we'll have 2 power management boards, we'll have 3 occupancy detection boards and 7 point control boards and 1 power meter. And that will be what goes into Sheffield. This is an interesting aspect about how we're going to control this particular yard. This is the new panel design for Manchester that we intend to use going forward, replacing the old ones, which are about 15 to 20 years old. There's nothing particularly wrong with them, except we're adding points and circuitry into Manchester, which has to be reflected, and so it's time to revisit it. This is the size of panel we'll be using, and in Sheffield we're going to be using 2 identical panels, and I was just going to position one now up here and show you what it looks like. There'll be one here for the Western shunting guy, and it's in a similar vein and works in the same way as London and Manchester. It'll obviously be different because of the track work. And then the other one is going to be up here for the other shunting man and the station manager. The final bit I'd love to give you a bit of detail or a bit of insight on is how we do all the testing prior to us screwing the boards down finally and putting all the missing track work in. What we've done is produce large-scale drawings without anything on them, and what we're doing is we've got the bundles of wire down there, which we'll show you a picture of in a moment. All of those have got to go either to a BDL or straight to a PM42 power district. And the crucial thing is checking that we have the right wires joined to the right tracks up here. So as a demonstration, just show you what we did here, well, this is the black circuit. I've connected to the zone, the black continuity wire, which would be for the C yard, and I'm checking with a simple continuity meter that all the black sections are working, and for example that the frogs aren't working where the point is thrown the other way, although we specifically test them separately. And this one will work, and here, and here. And then we also need to double check that actually have we got continuity across to the other board. So this, which is in the same power district, there's no continuity. Alarm bell, no. We actually have double checked and we have a separate black wire for the same power district coming from this board down, and we checked that and that's good. What we did find when we tested this was we did not have, found that we did not have a pair of dropper wires ready for this point on this power circuit. We do have dropper wires for all these circuits here, including these, and one of the things I would just demonstrate is that we know that this black is wired through, as is this black here, there. But we don't have one for that point, and that's crucial because we don't want to be putting that in once we're starting to screw the boards down and putting the point in. We need those droppers there. And we also found just down here that we've got an electrical fish plate, a metal fish plate here, and it needs to be an isolating one because this is part of a refuge siding, not the ladder going in, the point matrix going into the arrival departure tracks. Separately, so that covers the track and circuits and all those things, is we then have a big diagram printed out with associated documentation for every point on the layout. And we use a simple 9-volt battery, and we take the 4-core alarm cable we use, and we check that when we apply power to the tortoise motor, a 9-volt battery is strong enough to drive the motor, and we check that if it's black to black and red to red, the point is closed. It means that we've got that wiring around the right way. When it is closed, we also then check that that feedback loop I mentioned earlier also has continuity, and when we swap the polarity over, we also check that that wire breaks, that there is no continuity, so we know we've got the right switches joined up in the chocolate strip and on the tortoise. And the final thing we have to check when we change the points is that we do have the electrical connectivity between the points and here, because these are all electrically isolated from each other. And when we've done all that, we've checked the feedback from the infrared devices, we've checked that they close, that they're powered, that they do trigger, then we can be fairly confident that when we start wiring all these boards up, we're not going to have short circuits appearing, we're not going to have dead sections of track, we're not going to end up with confusion and trying to work in a very confined space underneath. So hopefully that's reduced 95, 98, let's hope 99% of all the problems we might encounter. Never mind just, we've always got the problems with running trains and testing that out, but that's as much as we think we can do before we clamp the whole thing down and finish wiring up. So I think that gives you a brief overview of how we will be testing this phase, and before we get then to start running trains, we wire up then run the trains. There's one other aspect that we will need to test, and the boards are arriving later this week, and that's to do with the RFID system. So we'll be wiring all these up as well. They'll all be sitting on the boards, and we will be running train or wagons over them and checking that they are detecting correctly and behaving and reporting over the wireless network, and so we don't have any faulty boards here either. So we'll have checked that electrically everything that we can test and everything that's fitted is working. So I've got one guilty admission to make, and you might be looking at all this and thinking we're very tidy. I have to admit that we dragged poor old Tony up here, and he spent 3 days clearing this up because we are rather messy buggers, and it's unbelievable. So we've actually worked out that we need a day a week to just clean up the work every week so that we can go and find everything again afterwards. All joking aside, what you see here, this is the Sheffield bit in terms of from the boards up to laying the board, so putting all that temporary track work down to prove the design that Malcolm built, designed, testing that we can operationally run it, taking it all apart again and actually wiring it all up. I wouldn't be surprised if we've expended probably 2 man-years of effort to get this far. And there's probably another 1.5 months to get all this stuff all wired up and tested. And then we've got another 4 or 5 months of operational running in here to actually just prove the whole system works, and that's not level D. So I've always been a bit optimistic on time, but just going forward a second, this will be a real milestone, because now we've got this temporary loop in here, we can run the Hades connection, which it surfaces up here and comes out onto the main line there. It descends down over there. We'll be able to test this operationally with the computer, also with the database software with RFID. We'll be able to prove RFID works in this big yard here, and just technically run trains. So we will not be doing any baseboard construction, so to speak, for at least another 6 months. So I don't think we'll be starting on the final level for Halifax and Wakefield until later into the summer, maybe even the autumn, because there's so much we want to prove and test and bed in so that it isn't hidden underneath and we can get to it all relatively easily, and just make sure that we've got everything lined up. Then we will then go on with Halifax and Wakefield. And once those have gone through the same testing, they're not quite as rigorous or intensive as this one, it's big, and all this lot will have been operationally tested. So we have a much smaller aspect. The line up to Halifax and Wakefield comes up this board here, goes round, and then it'll be a smaller component. Then we'll start to do the scenic work. And once we have got a serious component of the scenic work out of the way, all that dust and mess, then we'll take the tracks through. We might achieve that this year, though somehow I think reality tells me that we've never been that quick. So it might be 2021 before I can actually connect up and run trains from one room to the other. But by this summer, we'll be running trains intensively on here, storing trains in Hades, bringing them up, taking them back down, testing the time machine model, and all those things. So there we go. Thanks for watching.